Okay, hello, this is Dr. Janes, and today I'm going to talk about how to build the Sonic Devastator. This is a device that I built. It's way more powerful than the dog device that I showed on some of my other videos, the dog zapper. And it's really, really powerful. I built this to do some interesting science experiments. And I'm going to put some earplugs in before I turn this guy on. It is super, super duper loud and annoying. It is super, super duper loud and annoying. Okay, let's take a look at this guy. See if we can see that. There's the interior of it. Okay, let's take a look at this guy. It's got a Skar speaker on it, rated for 150 watts, CW. I did have it at higher power, but I blew out one of my speakers. And there we go. I have a knob to adjust the frequency and a knob to turn it on and off, and some 18650 batteries that I can take out and replace, 4 of them. It runs at about, let's see, 4 times 4 is 16 volts. I had it at twice that voltage and it burned out my speaker after a little while. And we're going to do some testing with this, and I'm going to show you how to build this step by step. Okay? Okay, here's a squirrel. He is way far away down there. Let's zoom in on him a little bit more. There we got her. Okay, he's about 30 feet away, and here is our Sonic Devastator device right here. He is gone. He took off. This thing is really loud. Squirrels do not like it. Okay, here's another cute little squirrel, and here is my Sonic Devastator. Oh, he's gone. They do not like this thing. Okay, so here's my Sonic Devastator that I just built, and it has the on and off switch here and a knob to change the frequency. And I just put some water in here because I was just curious about how water would interact with the sound waves from this device.
What the hell are you doing?
Just testing something.
Can I come get my clothes? Where are you?
Okay, so I guess this thing is pretty loud and annoying, so I'm just going to start out with it in the ultrasonic regime and twiddle it down and see if okay, so that's just the sound waves interacting with the surface of the water, creating disturbances there. Okay. pretty powerful. Okay, so let's just set up another experiment to test out our Sonic Blaster thing here. And I have some salt. I guess I'll use that. And this is a lid to a crock pot. And here's the part of the other part. I didn't bring the whole thing down. Now we have some saran wrap here. Here we got the saran wrap. It's starting to get all stuck to itself. And oh, look at this. It's one of those neat ones where it's got a little thing you slide across to cut it. That's so cool. I wonder how that works. Okay. And we got our saran wrap, and I think I'll just stretch it over this lid. Get this lid off of here. Stretch it over the lid, kind of like a drum or something. Could probably use anything. And it's all wrinkled up. You know what? I'm going to start over with a new piece because that one got all tangled. Oh, come on. Oh, saran wrap is cheap. Here in the pre-apocalypse era, the phony coronavirus. So we'll just be a little bit wasteful, I guess. Oh, come on, really? Stretch this over top of this guy. Let's see. Tighten him up like a drum, kind of. Oh, this stuff is so great. It just sticks to everything. Okay. I'll try to get that flat so there's not too many wrinkles in it. We'll see how this works out. Okay. There we go. And we'll set this into our crock pot like so. Let's take a look here. Okay. And see if we can let me get my earplugs in first. Okay, so here we got some salt. Okay, and let's just put some salt down on this thing. Yes, there's still some wrinkles in it, but let's just test out our sound device. Here we got our super powerful sound device here. I'm going to start at low frequency. I'm going to sweep the frequencies around and blast it at the salt and see if we can see the wave patterns in the salt. Okay, so it's not as high power, I guess, at the high frequencies. So I'm twiddling the frequency knob here, and it seems like it really puts out the power at the low frequencies. Okay, I guess I'll turn that off for a little bit, because that's super annoying. So anyway, more fun experiments with sound, and you can see this thing is really, really powerful. Especially, it's probably not as powerful in the ultrasonic. I'm going to try some other speakers and build some other devices also. But I'm going to show you how to build this one today. And anyway, here's what it looks like. It's got a clear body. Let's take a better look at this thing. Okay. So I actually bought a special clear tube from Amazon to put the electronics in. It's got an on and off switch and a frequency controller here. This is my power amplifier in this circuit. This is the signal oscillator and some 18650 batteries, 4 of them, all those high power lithium batteries. And anyway, very cool, huh? Here, let's get this out of here. Okay. My Sonic Devastator, Sonic Blaster, whatever you want to call it. Okay. And I'm going to show you how to build one of these in this video. Let's get started building this guy here. Okay. Very cool, huh? Okay, it looks like it finally came. And I think I know what this is. Kind of a unique package here. Let's see what we got here. Okay. Looks like it is my clear plastic tube for my project that I'm working on. Oh, that should be interesting. Okay. Can't wait to try this out. See if our speaker fits inside of this. It should, but sometimes you never know, right? Oh, it's gonna be so cool. Yeah. Okay, so we have our simple oscillator kit here, and the oscillator is basically the heart of any device that uses frequencies. And showed in my other video how to modify the input so that it doesn't go out of range and stop oscillating, because this annoying thing will do that. And here is the back. I'm going to have to hook up an external power supply, and I don't want to get a plug for it, so I'm going to just hook onto the wires here on the, or hook some wires like this onto the bottom of this guy. And I believe the back is going to be positive and the front is going to be the ground of the device. And so let me just start soldering these wires on. I may need something to hold this because this is going to get too hot for me to hold. Okay. Okay, there we go. So I have the two wires soldered on here. I believe the backer one is the positive and the front one is connected to the ground of this connector thing, so that should be the negative. And I've been putting together my battery supply, and I've never tested it at this voltage, although the PDF of the tech sheet for this chip says it should go up to this high voltage at least. I think it should go up to 28 volts, and I want to stick about, I believe it's about 14 volts. Each of these batteries, this is a 18650 battery, 18650, and I'm going to run them all in series. So it's about 3.7 times 4, and I believe when I did the calculations before it was around 14 volts. So this oscillator circuit should be able to handle that. But I'm just going to check everything as I go along, every step of the way, to make sure that everything's working. So that's the good engineering practice. You don't throw everything together and then try to figure out what the heck burnt out or something. You test everything step by step. And so I'm going to hook these up in series and make sure that the oscillator circuit works right, gives a good signal at that voltage. Okay, so let's test the voltage of our batteries, and it looks like they're a little bit over the 3.7 volts. It looks like they're over 4 volts each, I guess, when they're brand new. See, it says 3.7 on there, because 4 times 4 is 16, so we're getting over 16 volts on our battery test here. Hopefully that will work with our other devices. All of them should be rated higher than that. This one is rated up to 28 volts or something, so it should be fine, but we'll test it to make sure. Okay, so I'm not sure what happened. I blew out my chip over here, And I think I might have accidentally touched the lead to someplace it shouldn't have, but I checked the voltage coming out of the computer that's feeding this thing, and it's 5 volts. And looks like it does not like this voltage here. Okay, so I may have to put a regulator on this thing because it's not liking the high voltage I'm putting into this thing. Okay, I may have blown out my other chip. I don't know. We'll see. I have to test it. Looks like it is flatlined, so I blew out my second chip. So I'm going to have to wait until I get some new chips to complete this experiment. Okay. Okay, so let's test this out, the circuit. I just put a new chip in there because I burned out the old one. With 4 of these batteries, which is going to be almost 14 volts. And it looks like our oscillator is working fine. Let me just click that up. We can twiddle the frequency over here with the knob. And look at that. We can change the frequency. It looks like the output is working great at this voltage level. Okay, so we can go on to the next step. Okay, so here's our oscillator, and here's our amplifier circuit. And I think what I'm going to do is I'm just going to take some electrical tape, because I want to put these maybe back to back. Looks like they will fit together, and I'll be able to conserve space if I stick them together like that. But I don't want them to short out, so I think I'll just put some electrical tape along the back side of maybe both of these. And here's our electrical tape. And see if I can find the end of it. Let me fiddle with it. Okay, so let me just take this electrical tape and I'll cover the back of this circuit for sure. Okay. And got my handy dandy razor blade here. And I might put some more tape over the back of it because I want to completely cover up any circuit that might be exposed. So there's a short to this guy over here. Okay, so I think I'm going to solder the power leads together for the amplifier and the oscillator circuit. And we have the lead from the input of the FET driver here coming around the back. And I'm going to attach it to the output of our oscillator. And we'll do some testing to see if we burn this circuit out or not. Hopefully this voltage that we're going to be using with these batteries up here, 14 volts, is going to be acceptable. Okay, so I'm just soldering these guys here. Put some solder on it already. Okay. I think we should be all set to test this now. See if it works or if we burn it out with the higher voltage. Okay, so we have our oscilloscope hooked up here, and I'm going to test it on the input to the FET. Okay, so that's coming out of the oscillator and going into the FET driver. The stupid thing keeps on turning off. Okay, so I'm going to test it coming out of the FET driver. We're getting a good signal there. And I'm going to test it going into the gate of the FET here, right up there. And so it looks like we have a good signal all the way up to the gate of the FET. So we should be getting power through this whole circuit then. And I guess we could test it at, I'm going to add more batteries on the FET output, so it'll have a higher voltage driving it, and hopefully I'm not driving the gate too hard and damaging the FET, but we'll test it and see if it works okay. And we might hook it up to the speaker and see if we can make some really loud sounds. So I think that we have a good signal all the way through up to the FET, assuming we're not damaging the FET gate by putting too high of a signal on it. I think we should be good to go. Okay, so here we have our circuit, and remember the speaker has preferred polarity, has a plus and a minus on the back of it. Let's take a look here. And so I'm going to hook the minus to the top side of the switching FET, or basically the output of the FET, which is going to switch it to ground. And the plus is going to go to the battery side. We're at 14 volts. And here's our speaker and our oscillator, and we'll just test it. Okay, I'm not going to do it for too long because it's super loud. And, oh, by the way, here, look, I have my earplugs in because it's really, I don't want to get ear damage, and it's really annoying and loud. Okay, so that's with 4 batteries. And I might go ahead and just add the extra batteries on and see if we can drive this thing at super high power and test it like that. And then I think we'll be able to start getting it ready to assemble in the tube. Okay, so according to my calculations, to reach the power levels that I want with this device, I'm going to need about 8 of these batteries. I have 4 of them in these 2x2 cases, and need 4 more for that. And here's our form factor. I want to fit it into this tube here. Okay, and so I figured the best way to do that is to make them go back to back, and so they're not all floating around inside of there. I think I'm going to glue these 2 back to back, and maybe I'll glue the whole thing together in a giant power pack. But let's just start with this, and I have my hot glue gun, and so let's glue this guy. Okay, get some glue down on there, and before it hardens, let me get this second battery pack on top, like so. Okay, let's see, we're still taping. Okay, and hot glue is great. It dries really quickly, and this is like super solid. And just to make sure, always testing everything. Make sure it fits into our package here. So that's looking good. Okay, so maybe I'll glue these other 2 together, and we'll see if the whole thing fits inside this tube like it's supposed to. Okay, just doing a test fit of all the components here, making sure everything looks like it's going to fit in there. And so here's a speaker, here's our driver circuit and oscillator, or amplifier and oscillator, and our battery pack. And looks like everything is going to fit. It's going to be close, but I think it's going to be doable. Okay. Okay, I think I'm going to push the wires off to the side and glue these 2 battery packs together like so. So it'll just be one big battery pack, so it'll come out as a unit, and I think it'll be easier to work with if I got it all glued together. Okay. Okay, maybe I'll just connect them so I don't have to worry about crunching the wires. I'll just connect them back to back, like so. And stick them together like that. See? Okay. And then I'm not running the wires out sideways or something. This hot glue seems to work really good. Look at that. Awesome battery pack, huh? So that's going to give me 28 volts about. That's super high current. Should be awesome. And let's see, I'll just plug this into our tube. There we go. It's into our tube like so. Okay. I think we're going to be all... Okay, so I just got the first battery pack activated, and I'm just hooking up clip leads to test everything. I'm hooking up the oscillator at 14 volts, and our amplifier is going to be run at 14 volts. And then in a little bit, I'm just going to test this first. So it goes from the output of the FET here to the negative of the speaker to the positive, and I'm going to put a capacitor in here to match that in a little bit, so it should put out more power. And then the top end of the speaker goes to the 14 volts positive, and it sounds like it's working. Okay, so now I'm going to add the second battery pack. Remember, you can't run the oscillator at that high a voltage, but I can run the amplifier at an even higher voltage. So I'm going to hook basically the negative of the second group of batteries to the positive of this one, and so they'll sit at a higher voltage up above that. So I'm going to solder those together, and this guy will still get its voltage off of the lower voltage part, and then I'll hook up the speaker to the higher voltage part, make sure I don't blow out the FET, and make sure the speaker can handle that much power. And we'll test it out at an even higher power level, at full power. Should be interesting. Okay, I guess while I hook those up, those are actually eventually going to have to hook up to the positive of the oscillator and preamplifier. And so I'm going to actually cut the wire. I'll just solder all three together at the same time. These two, the connection from the front of the battery to the back of the battery, and a connection from this midpoint, this middle voltage point, to our oscillator preamplifier. But I want to have enough wire so that I can pull the battery pack out the back. So I'm going to measure out enough wire against this tube so that the battery pack will clear the back output of this tube, so I can replace the batteries. So I don't want to have to disassemble this whole thing every time I want to recharge the batteries. And so here we go. I'll clip off a red lead, I think, and solder it to the front here, the positive of this oscillator circuit, and then to this midpoint of the battery. Okay. Okay, so I have the positive of the front battery hooked up to the negative of the back battery to a third lead, which will be the power connection for our oscillator. And let's see if I can solder all this up while holding the solder and the camera and a soldering iron. I strip back the wires a little bit so that they will wrap around this thing, so I don't have to hold everything in place all at once. I'll make the solder joint a little bit stronger. Okay, I think I'll get this soldered up, and then we'll wrap it up with electrical tape so that it doesn't short out with something, because we don't want things shorting out inside this thing once we get it together. That would be bad. Okay, so here's our three wires that are hooked together, and we'll just wrap this guy up with electrical tape, like so. Okay, and then we will test this guy out to make sure he still works. Looks like it's still working. Okay. Okay, so let's solder this red wire that comes from between the batteries to the VCC connector of the oscillator and amplifier circuit. Okay. There we go. Okay, and we'll give this thing a test, probably at high power, total high power, and see how it works. Should be very interesting. Okay, so I think I have the positive part of this hooked up from the battery top-bottom junction to the VCC of the oscillator, and I'll hook up the bottom power supply, and again I guess I will test this at the middle voltage. Okay, and it seems to be pretty loud. And now I'll test it with the full voltage by connecting it to the other batteries in series. I don't know, I have earplugs in. Does that sound any different? Yeah, I think that's louder. I see it sparking when I touch it. Okay, I think that's very loud. Okay, let me shut this thing down. And it looks like our circuit's coming together. Okay. Okay, so I have these extra leads that are in series on the top and the bottom battery, and I taped them off so they don't get into trouble. But I think I'm going to hot glue them down as well, just so that they don't get in the way. Okay. And I'll probably hot glue the other ones on the other side maybe, so there's more room over there. And that'll get them out of the way, keep them out of trouble hopefully. Okay, see I have another pair over here, pair of freaking leads that are used to put things in series. Okay, let me just hot glue these in place. And that will hopefully keep them from getting tangled up and stuff. Make the battery pack a little bit more compact. Okay. We'll just let that dry for a second, and then we'll continue on. Okay, it looks like these speakers come with a matching capacitor, and maybe I'll just see if this helps. I'll just hook it into the circuit and see if it helps match it and make it louder, if it's worth putting in or not. Okay. Okay, so here is this device without it. Doesn't seem like it makes it that much louder. Maybe I'll not stick it in. Okay. Okay, so now I need to run a second wire from the back of the battery, the high voltage side, all the way up to the positive side of the speaker here. And I'm going to stretch this thing out to its full length, because remember we want to be able to have it come out of the tube. Here's our tube. We want the battery pack to be able to come out of the tube so we can change the batteries. And so I'm going to need a wire that's going to go from all the way from back here, all the way, I'm just going to have to stretch it all the way up to the speaker in the front, and give it enough room for it to slide out of the battery pack. So I'm going to measure out that length of wire, and I think I might run it right up next to this other wire, so there's not too many wires springing around. Maybe I'll tape them together, and maybe I'll tape the ground wire also. So we'll have 3 wires, just a single wire basically, three wires all taped together, going to the battery pack, so it's not a big old mess. Okay, and we'll measure that out and solder that up. Okay, soldered this back wire. I changed my mind about the front wire. I just tinned it up. I think I'll just pull out that old wire, because you're like push-on connectors, and I'll just put this in its place. It should work. Alright, we just push this guy in, and we can remove that wire. And we should be able to see that this thing is kind of sharp, and it kind of cuts the wires after a while. So if I tin it up, maybe that will use a thicker wire. So we got that front one clipped in there, and I'm just going to tape up this back one here. Let me tape this up. We definitely don't want these things shorting out someplace. That would be so bad. Oh. Okay. let's tape this guy up. Come on. And I might just tape these two wires together so they are not springing all apart when I pull the battery pack out. And again, I keep on testing this as I build the circuit to make sure I didn't do something to pull a connection apart or something. So I keep on testing this guy, making sure everything's working properly. Okay, so I'd like to be able to turn this whole thing on and off with a single switch. Here I have a little switch here. And so I'm going to run a wire, well, I'm going to put the switch on the ground side because that wire is common to everything in here. Remember we have several positive voltages. We have it, actually I measured it, it's not 14, it's actually about 16 volts coming into here, and it's about 32 volts coming up to the battery. These are actually higher voltage than what they're claiming. They're actually almost a little bit over 4 volts. And so if I put the switch in the ground, this will be able to turn the whole thing on and off. And that's what I'm basically doing right now. Is the only wire that's not connected is the ground wire. And so I'm going to run a black wire that's long enough for me to route this switch where I need it to go up into the fuselage or a tube. And then I'm going to have to hook a second wire that's going to go back from this to the battery pack. That's going to have to be quite a bit longer. And so I'll measure those wires out. And hopefully we'll have our circuit completed then and ready to start sticking in the tube. Okay. Okay, there are some holes in the contact, or the, what would you call it, the leads of the switches. I don't even know what you call them. And so I threaded my two wires. I have a longer wire here, a longer wire and a shorter wire, and I threaded it through the switch. And we will try to, oh gosh, solder this thing together. Ah, come on. Here we go. Try to solder this thing together. Okay. I'll solder both these contacts on, and it's not easy doing this holding the camera, so let's get this done. Get her done, right? And I'll show you the finished product. Okay, so there's the finished product, and I might try to clip back these uncoated leads, or maybe put hot glue on them or something, but let me test out the switch and the circuit and make sure it's working fine. And we'll solder up the rest of the way, and actually I have one more wire to solder from the speaker onto the output of the FET, and then I think our circuit will be good to go, and we'll just need to work on drilling a few holes in the tube and putting on the plate that's going to hold the speaker, and maybe an end cap, which I haven't made yet. Okay. Okay, I just soldered the ground wire of the switch onto the ground of the battery pack, and let me just tape this guy up. I've been taping up everything else. Make sure that it doesn't short out, because this would be a bad one to short to like the high voltage side. Start a fire inside your device. And I don't know, maybe I'll tape these together also. Let's see. Might be good taped right about there. Tape them all together so that the wires aren't all spaghetti and getting tangled up. I try to take the battery pack out. Okay. So we'll have 3 wires, one ground and medium voltage and a high voltage out. And when I say high voltage, it's not really high, but 16 and 32 volts. Okay. And now just hook up the other end of the switch to our circuit here. and we'll make sure everything's working properly, and then our circuit should be finished. Okay, it seems like I might have burnt out the speaker because it seems to be open circuit now. So maybe that was too much voltage to put onto it. Because let me test this other one over here. Okay, so when I hook up this speaker, I'm getting a short circuit, basically 3 ohms. And the other speaker seems to be an open circuit, so it seems to. So that's not good. I think I burnt out this speaker here. So maybe I can't put the full 32 volts on there. Okay. I may have to scale it back. Maybe I'll cut my battery pack in half and just live with that. Okay, I guess I'm going to do a redesign. I cut this battery circuit out, and I'm going to hook what was the high voltage side up to the normal voltage, so they'll both have the same voltage. So I'll just be driving the speaker at half power, because obviously driving it at the 200 watts like they claimed that it could handle, it couldn't handle it. It had burnt out. Right, let's see, what does it tell me? It tells me 240 watts max power. Okay, so maybe 120 watts RMS, so I guess that's only peak pulses, so since I'm running at CW, it did not like that, and I burnt out one of my speaker elements, unfortunately. But fortunately, I have a second one because they come in pairs, and so this one should be good to go. And I'm just going to solder these 2 wires together, and we'll continue testing the ground, make sure everything's working fine, and our switch here. And then if our circuit looks good, we will stick her inside of the tube here. Okay, so I've removed the extra battery pack. I might tack down these wires again, because they're kind of floating around there. And I haven't soldered the last wire on, I just have a clip lead. And just testing out the switch here. Oh. Let's hook up the speaker. This is our last working speaker, because it looks like we burnt out the other one. And we'll flip her on. So it looks like it's working okay. Flip the switch on and off. Okay, we're able to change the frequencies. Looks like everything's working fine. Okay. Oh, come on. Okay, so I think our circuit is all good to go. I'll just solder up this last wire, and then I'll work on trying to do the mechanics of sticking it into our tube. Okay. Okay. So here's our switch connector, and I'm connecting it to the ground of our oscillator circuit by soldering it in place. And I'll solder it in place and then tape it up. Yeah, soldering iron's hot. Okay. Be careful not to drip solder on the circuit, I guess. Okay, there we go. Okay, so here's something that I, basically a holder for this Skar speaker. Cool looking, kind of a cool looking speaker. Just burnt one out, putting too much power through it. Anyway, this is for my high power Sonic device, which I'm building over here. And I'm going to post this on Thingiverse, so I'll have a video for that. Or maybe this will be the video. And so what the idea is I want to have some way to mount this speaker and into this tube so I can have a compact high power device. Skar speaker comes with this ring here, and this ring here that I designed goes right over the top of that, and then we can put this metal ring back over that like so. Now okay, let me get the holes all lined up. So this Skar speaker comes with these screws, and they are way too long. They're anticipating that you stick this through some probably thicker material, and I didn't want to make this holding plate that thick, so I had to get some shorter screws because the other ones were bottoming out. Oh, actually, maybe I'm going to need the longer ones because these look like these are going to be too short. Try these. Okay. These Skar screws in here. Yeah, see, those are too long. Maybe I'll have to cut these off. Jeez. That's no good. Well, let me fiddle with this. See if I can find something else. Okay, I guess these screws were probably be optimal to have them a little bit longer, but looks like I was able to get a couple threads in with these guys. Screw that guy in. Of course, if you notice, I'm using a Phillips screwdriver to screw in a hex head. I just tilt it a little bit and it grabs onto it. Someone said that anyone can do the job with the right tool. It takes an engineer to be able to do a job with the wrong tool, and that's definitely the wrong tool. Okay, let's see what we got here. Here's our tube, and I made this so it just barely fits in there. So we'll get this plate on here. Okay. Now let me get this thing. Oh, I guess the screw came out. I'll fiddle with it for a second. Okay, so there's what our speaker looks like, mounted inside of our tube. And well, I'm going to have to probably drill some holes in this thing. And well, maybe I may need to hot glue this plate on here because I don't want the speaker to come off and destroy the unit. Okay, so that's what that's going to look like when it's finished. And let's see, maybe I'll mark out places for the switch and the frequency tuner, and should be interesting. Okay, so there's what the mounting plate looks like, the speaker mounted inside of it, and looks pretty nice. And let me get these holes drilled, I guess. Marked off some places to drill holes in our plastic tube, and I'm going to get a potentiometer and a switch to measure out the size of the holes, and hopefully we'll get this done. Okay, so I have marked out the holes where I want the two different feed, or I don't know what we call it, feed throughs, I guess. Front one will be for the switch, because I prefer to have the knob that I twiddle with back further where it's more accessible. And I'm going to start with a smaller drill and start drilling bigger holes. I think this one's going to be close to the size of that guy, but probably not quite big enough to get it through. So you can compare the size of the shafts of the two guys. And this one's probably going to be long enough to get the screw through, but this other one I'm questioning. I may have to countersink it because the threading's not that long. But we'll see. We'll start drilling holes, and we'll start here. So, and I'm going to put the camera down because I need to hold this tube so it doesn't roll while I drill on it. Okay. Okay, I'm going to drill these both through, and then we'll size them up and see what size next we need to go. Okay, so it looks like that hole is too small for the switch to go through. I'm going to have to go with a smaller or larger drill. And it'll definitely be too small for this other guy over here. And so we'll go next size up, and I have some other drills over here. These are crappier drills, but I have more of them left. For some reason some of these disappeared. I think I let someone borrow and use them, and they didn't return them properly. Okay, so here we'll just size the holes up a little bit. Have a bigger drill bit on there now. there it is. Oops, let me get it started first. And there we go. We got our 2 new holes in there. Okay. We'll test out the switch. Looks like that one is too small for the switch to go through. Gonna need a bigger drill bit still. It's getting close. Okay, so it looks like that one was big enough for this thing to go through. Yeah, let me feed it through the inside. Oh, come on. So let's see if there's going to be enough threads on the outside of that one to screw it down. So we should be good to go. And this one here, I'm pretty sure is going to need a bigger drill. Let me test that out. Okay, so it looks like this drill bit made it through. I believe that was a 5/16. I'm not sure what the other one was. It was smaller because I had to use my crappy drills over there, and I don't think they have designations on them. But let's test it from the inside and see if we got enough threads to thread it out. I may have to countersink this a little bit to be able to thread this guy in. Okay. Okay, this guy is definitely not getting the threads through. And I'm not sure. It's kind of not fitting in the tube too great. Gotta be careful when you countersink it because you don't want it to tear all the way through, make a big hole, and then not be able to just completely ruin the part then. Seems like because the tube is so curvy, these are not fitting in there well. Maybe I should bend these tabs down. I don't know if I can. I'll have to fiddle with this some. Okay, so I'm going to go with a big ass drill now, and I'm going to have to go very slow and very carefully. I don't want to, if you get going fast, the drill will just pull itself right through the hole. And I'm going to have to grab this with both hands. Okay. Just go in. Little burst like that to make sure I don't cut through. Okay, it looks like I've countersunk it quite a bit, and there may be enough room to get some threads on. And I'm not going to be able to put the washer on, that's for sure, but let's see if we can get the threads on this thing. Okay, I'm going to have to put the camera down to do that. Looks like we might be able to get some threads on, and this might be good to go. Okay, I think we can get more threads through if, either we break this part off, which I don't think we can do that because that's part of the circuit, or maybe cut this little tab off. And so I have looked around and I found a pair of dikes here. You probably want to either wear safety glasses or close your eyes when you do something like this because that part will go flying. And get it lined up. If it gets too high, that could be a bad thing. Snip that off. We'll see if that helps get more threads in. Okay, that definitely did the trick. If I orient it like that, and I cut that tab off, I can get enough threads on to hold the potentiometer in place. It's not easy to screw it. I wish I had a bigger, big drill so I could have more room around the threads here, but I don't. That's the biggest drill I got, which is a 1/2 inch. So let's see if I can get this potentiometer back out, and we'll snip the other ones and try to feed them into place. I think we should be set to go. Okay, I wanted to kind of do something to protect these trimmer capacitors here so they don't short out. And I mentioned putting hot glue over the tabs here. I think that might help that situation. Okay. And so we'll just hot glue those tabs up and make sure this thing doesn't short out. And then I think we'll be set to try to insert it into this tube, see if we can get everything in there. Might be a Chinese puzzle trying to get it in, but anyway, we'll see what we can do. Okay, so I kind of got all the wires organized, and I'll just try to feed it. Get everything in there. Feed it up inside the tube here. Make sure everything fits. Okay. And then I will try to get these pots in place, especially the back one. That one's going to be difficult. And then front one, then I'll try to bend the wires and get everything up to the speaker. And I think we'll be golden after that. It's looking good. I have to fiddle with that pot to get it through that hole and get the nut on it. That'll be the first obstacle. Okay, so I got the potentiometer through the hole. And here I have one of my nuts here. And how am I going to do this? It's going to be tricky to do this with one hand. Okay, so I got to feed the nut over the stem thing here and try to screw it on. And it's hard because this hole is not much bigger, so I need to use my fingernail to get in there. I think I got threads on the other one, so I should be able to get it on this one. And let me fiddle with that. Once I get that one in, then the switch will be the next part. And I think we'll be all set then. Okay, so it looks like I got the nut on there with enough threads to hold it in place. And the next thing I got to do is get the power switch up to the front, rotate that into position, and then screw that one on. Okay. Looks like we're doing pretty good. Okay, it looks like I have the front switch through the hole also. I just need to get a nut and stick it on there. So how can I do that? Okay, let me put the lock washer on first. Okay. And we'll get the nut on there and screw that down. I just need to tighten that up, and I think we're pretty much golden. Let's see. Just need to slide that circuit up now. Get the wires out the front end. Okay. Now, I think I fed this circuit about as far as I can go. I thought I could go farther, but I guess it's interfering with the pots. But I think the wires are close enough that I can hook them up. We have these push-on connectors here. I'm going to connect the black to the low side, the FET, and the red one to the longer one. That one easily feeds out, so let me get that one connected up first. Push on the connectors, feed it in like that, and we'll get the other one connected up, and I think we'll be good to go. Okay, make sure the battery pack fits in. I guess I made these wires a little bit too long. Let's just stuff them in there. Okay, there we go. And good on the top plate, I made these glue this top plate down so it doesn't fall out when I'm using it. And let's just give her a quick test. Whoop. That thing is really loud. Okay. And I think I need to make one last end plate to stick on the back also. Okay. I think we're pretty much all good to go here. My super high power Sonic Devastator. Okay, so here's my Sonic Blaster. Okay, so here is my Sonic Blaster. And here I have a 3D printed end cap that I got from the local library services. Let's test fit it in there. It looks like it fits in pretty nice. Okay, and so there is the end cap, and our device is complete. And I will be posting these STL files on Thingiverse people want a copy of them on my Thingiverse account. And, okay, I'll have to go test this device out. It is looking pretty nice, huh? Super high power Sonic Blaster.